comes with data. We started with variables. I've also noted down variables as one of the key part that we had covered, and it's always the key part. So range, standard deviation, Leonard range, and box plot is something new to you. Then outliers is something new, variance is new. Then what we studied variables and 5 numbers summary. Now before we went off for break, we had request which we were requested to share your results. So are you all prepared with your results? Did you utilize or did you get some time during the lunch hours to do those calculations? Thank you, Shehzadi. So if you could kindly share your results, what is the standard deviation that you got and what is the variance? Very good, very good. So we have first correct answer. We have first correct answer from Ikra. Saroja also replied yes. And we also have a reply from Shehzadi. If you could share your answers. If you could all very quickly share your answers. Yes, Saroja, you're right. Okay, do we have few more answers? Anybody else who tried during your lunch hours? Okay, Shehzadi tried, correct answer, and Pallavi tried, correct answer, and Nasneem tried, very good, Bhagyashree tried. Anyone else? Let's wait 30-40 more seconds to get responses from everyone. Okay, so we have Madhura who's given good answer. We have Sapna who's given good answers. And we have Swati, very good Swati. What about standard deviation? Good Swati, good. Sanjana, Chandrakala. So all of you have given correct answers. Asma also gave good answer, correct answer. So I really appreciate you all. Madam, all your students are very studious and hardworking, and they are smart as well because they learned it very quickly, and then they are now sharing results. Ambika, Asma, Ambika, Devala, every one of you have given right answers. Any other participants who want to share? We will quickly wait 10 more seconds and then we will proceed. 10 more seconds. Anybody after Devala? Okay, Ramya, very good. So we are receiving good answers from everyone. Thank you, Rashmi. Appreciate. Rashmi. Okay, so let's now proceed forward. What we have seen, okay, Amadi, good answer. What we have seen till now is now how to describe data with numbers, measure of center and measure of spread. Now in the second half, we are going to look at how do we do that in Python. But in addition to that, we are also going to look at how do we describe data with plots. Okay? As we understood earlier, that it's not only the numbers that are really critical in helping us understand the overall data because we look at dealer 1 and dealer 2 case, where in most of the case, mean, median, and mode probably would be same. The range would be different, standard deviation would be a little different, but still to understand how is the overall distribution of the data, we need to look at, we also need to look at the charts. So in the second section today we are going to look at how we will describe data with plots and combine describing data with numbers and describing data with plots is what is known as exploratory data analysis. So this is a new topic for everyone. Before you go to machine learning, before you go to artificial intelligence tomorrow, the most important is to use the statistical measures we have seen till now and also use the exploratory data analysis techniques that some of which we have discovered, we have discussed, and some of this we will be discussing. Once again, let me just confirm from all of you if my audible to you. Is it good enough? Is it loud enough for you to understand and grasp? If anybody can reply on the chat. Yeah, thank you, Ramya. Thank you, Pradeep. Thank you, Chandra. Okay, thank you, Lord. So now we are talking about exploratory data analysis. Thank you. So exploratory data analysis is the critical process of performing initial investigation on data. See, this is important. What are we talking about is only an initial investigation part. So exploratory data analysis does not help you to derive conclusions. It does not help you develop models. But what it does is help you to perform initial investigation in data. And this initial investigation is as crucial as a doctor investigating your case before giving you out medicine. And so just assume that you go to a doctor, you go and sit there, and then you just tell him that I have fever or I had problem in my legs, and then doctor, without looking at your history, without looking at your pulses, without looking at the overall your body structure, it comes and simply give you some medicines. Is that will those medicines work on your body? Will those medicines really work to cure your problem? So that's not possible. So exploratory data analysis does the same thing. It makes you a data doctor, where if you become a data scientist and before applying your machine learning and AI knowledge, you can spend some time in investigating the data so as to discover patterns. Okay, please read this. Please listen this carefully and read out on your chart on your screens. That what exploratory data analysis does is it helps you discover patterns in data, to spot anomalies, to test hypotheses, and to check assumptions with the help of summary statistics and graphical representation. Right? We had certain assumptions. For example, when I said that you're driving a red Ferrari, you're driving at a speed between 100 to 120 kilometers per hour. Now, this is an assumption that we did. Okay, when you reached home, I asked you, okay, what was your average speed? How are you driving? You told me I was driving between 100 and 120. But that's an assumption for me. How can I validate that assumption? So to validate that assumption, what I need to do is you need to use summary statistics and graphical representation of those summary statistics, those data that will help me further validate that yes, whatever you said was right. For example, dealer one and dealer two. Now both of the dealer says that okay, we sold 12 cars in a year, and both of them are right. But until and unless we go and do the summary statistics and graphical representation of it, we will never be able to understand the difference between both of them. Right? So now, the first point, it helped you to discover patterns. In the earlier case, when we were trying to understand what are outliers, where we had good discussion, where are the 19 data, there are 15 data in a cluster, and others are outliers, or others have they were slightly away in the chart. So those are called patterns. So it helps you identify patterns. Some pattern might be seasonal. For example, you own an ice cream parlor, okay, and then you want to understand how is my sales performing, or how does my sales vary with time. So you will realize that whenever it is summer, your sales are more, and whenever it is winter, your sales are less. So this is quite an obvious thing. Usually, people do not prefer to have ice creams during winter, and people prefer to have ice creams during summer. So there is a pattern in your sales that yes, during summer my sales increases, and during winters during my sales decreases, and then it again increases. Right? So these are some of the patterns of the examples that help you identify them. Now, suppose you are ice cream parlor owner, and then suddenly there's a then you get a then you get an order for wedding, and in the mid-winter, you suddenly your sales peak up. Okay, usually your sales remain flat during winters. People don't flex off, but then you got an order for a wedding or a party or a birthday party, and then suddenly you got peak in your sales. So something which is not normal or something that does not fit into a normal distribution pattern is known as an anomaly, right? So it helps you identify those anomalies. Overtaking a vehicle that was equally driving at 100 kilometers per hour. To overtake the vehicle, you had to increase the speed till 150 and then you came back to normal to say 120 or 100 kilometers per hour. So that 150 becomes usually this anomaly also helps to identify patterns of failures, right? For example, if the motor is running, and then suddenly you observe that okay, the current consumption of motor has started increasing, it has started peaking up. So that anomaly helps you identify that yes, something is wrong in the motor, and it may lead to a failure. So it is a good practice to understand the data first and try to gather as many insights from it as possible. So exploratory data analysis is all about making sense of the data in hand before we start building the model. So exploratory data analysis is used by data scientists. Yes, it is extremely useful, extremely critical to analyze and investigate data sets and summarize their main characteristics. So it helps determine how best to manipulate the data source to get the answer you need, making it easier for data scientists to discover patterns, spot anomalies, test hypotheses, and check assumptions. Okay, so I'm sure what is this exploratory data analysis must be clear to you. You would be surprised that originally this exploratory data analysis was introduced by an American mathematician known as John Tukey, and it was introduced in 1970. So, friends, it's a truth that whatever we are studying now is decades and decades old, but they are still very useful today, and the use has just started building up. So now let's go a little deeper into understanding the exploratory data analysis. And here, what does it help? It helps you identify errors, patterns. It helps you identify outliers and anomalous events. It helps in developing initial relations among variables. Okay. Now we are going to see what is this initial relationship among variable, and it's going to be quite interesting to know this. But it helps you do this. So the main purpose of EDA is to help look at the data before making any assumptions. It can help identify obvious errors. It can help you identify, understand patterns or outliers. So data scientists use exploratory analysis to ensure the results they produce are valid and applicable to any desired business outcomes and goals. Okay, so this is important aspect. You remember I started saying this. When you produce an output from a machine learning model, see, those output must be reliable. Those outputs must be valid and must be applicable to any desired business outcome and goal. For example, you are making a study on COVID patients in Maharashtra, right? And then you want to apply the same fit to Delhi, Gujarat, Calcutta, and West Bengal and other states in India. So before you apply your learning that you had achieved from the data in Maharashtra, you need to be very, very sure. You need to be very sure that what you apply or what you study is applicable and it is valid across all the different states. Okay, so let me once again clear. For example, when you study when you study uh, the overall behavior of COVID in Maharashtra. Now we understand that COVID behaves differently in different demographics, and for example, it behaves differently in different age group. It behaves differently with a different kind of medical ability. It behaves differently in different ways. So when you study So when you study based on the data that is available to you from Maharashtra, it must include all the age groups, it must include all the demographics. There must be equal number of males, there must be equal number of females, there must be equal number of senior citizens, there must be equal number of kids. So basically, this is an example wherein whatever you study should be applicable to other states as well. Now, if you study something in Maharashtra where you only study for age group between 40 and 60, you don't study something for people who are more than 60 or people who are less than 40, and then you try to replicate it, and then you try to generalize it that okay, if it is applicable between 40 to 60, it will also be applicable between 60 to 80 and 40, and like less than 40. So that's not the right practice. So similarly, exploratory data analysis, it helps you validate that whatever data you have, and you have good variety of data, you have good spread of data, so that if it can be applied across one business function, it can also be applied across different business function, different city. Um, let's take another example of West Side. Now, West Side has stores across India, across various cities. They have thousands of stores. Now, you collect data of say 100 stores, okay, and then you identify, okay, these are some of my top moving products. These are some of the top behaviors of the customers who come at West Side, and these are some of my slow moving products, okay. When you do this analysis, the objective is once you do this analysis for 100 of your west side store, you want to replicate it across remaining 1,000. And when you want to replicate it across remaining 1,000, your analysis, you should be confident enough that yes, you have considered all the variety of data, that it can be spread across different stores of west side. So that is what exploratory data analysis help you understand. So ED also helps that stakeholders by confirming they are asking the right question. Okay, EDA, right question. If you remember, we started saying that the most important point is actually to define the problem statement. Okay, if you are the owner of an ice cream parlor, and then you want to know like why my sales are declining during winters. Okay, so is that a valid question? Because you know ice creams do not consume more during winters, and that's not a very valid question that you should help your stakeholders. When I say stakeholders, it may be your boss, it may be your mentor, it may be your client who has given you a problem to identify. You can simply say, okay, I need not to do any statistical analysis to identify why your sales are declining during winters. It's obvious. So that's a wrong question. You may say, okay, at some point of time, I realized that your sales during the period of summer declined by 5% as compared to previous 2 years. You were selling more than 1,000 ice creams a month, and now we are selling almost 990 ice creams a month. So there is a decline in your sales. Let me find out the reason. Why is it happening during summers? So that's a valid question. Okay, I'm sure every one of you must have understood. If not, you can raise your queries in chat. So exploratory data analysis can help answer questions about standard deviations, categorical variable, confidence interval. So once EDA is complete and insights are drawn, its features can then be used for more sophisticated data analysis or modeling, including machine learning. So with this, let's proceed further. And now our objective is what are the various different methods that can be used for performing exploratory data analysis. So one of them is what we know as univariate visualization of each field in the raw data set with summary statistics. Okay. So what is univariate variation? We're going to look at now. But univariate variation is something that you only plot one column of data. For example, sales. Now, when you plot sales with respect to time, you arrive to a conclusion that okay, the sales is cyclical, it is high during summer, it is less during winter, but then only that can only be done if you start plotting it. Or so that is known as univariate visualization. The second is known as bivariate visualization and summary statistics. So bivariate visualization is you want to draw a relationship between two different variables. like the cost of the ice cream and the sales of the ice cream. So the cost of your ice cream and the sales of your ice cream becomes two different variables, and then you want to arrive at is my sales dropping or increasing because of change in cost of the ice cream? Is there anything related to cost that is affecting people or that is stopping people from buying them? So when you analyze two different variables to come to a conclusion, that's known as a bivariate visualization analysis. From here, the last part is what is known as multivariate visualization analysis for mapping and understanding interactions between different fields in the data. So today we are going to look at univariate, we are going to look at bivariate, and we are also going to look at multivariate visualization analytics such as correlation graph. Okay, so going forward, when we look at these things into detail, I will ask you, please be polite enough to reply that okay, these are multivariate, these are bivariate, and these are univariate. So be prepared with that. Let's move ahead. Then there are certain practices that we are going to discuss in coming days. One is known as clustering practice. The other is known as dimension reduction technique. So we are going to discuss this. These are all statistical techniques and machine learning techniques that we will study. And we are going to use k-means clustering and predictive models such as linear regression. Use statistics and data to predict the outcome. So expected data analysis is a very vast thing and it's a very powerful thing. So how do we use it? How does it help us? We are going to look at it in some of the next sample slides. Now, madam, if may I request you, could you make the other Sunny the presenter, Sunny Desai main as presenter? So we can start with the demo of Python. Rashmi ma'am, if you could make Sunny Desai main as presenter.
Is she there? 1 minute.
She seems to be there. Yes, yes, she's there.
Achha, achha. Sorry, is she on mute?
We also have Pallavi madam here. If anyone of them can help us to make Sunny Desai main as presenter.
Where is Rashmi ma'am? No, she's not there.
I'm here, sir. I'm here.
You're there? Okay, okay.
Yes, sir.
You want to make Sunny Desai main as the presenter?
Yes, yes.
Okay. I think I gave you that.
Is my screen? Yes, yes. It's visible. Okay, friends. So right now, what can be seen on the screen is what we call as spider. So I understand all of you must have installed this fiber in your laptop. Spider. So Spider is basically an open source interface that helps you do the coding of Python language. And there are many other interfaces, open source interfaces such as
Yeah, lot of noise. Who is? Can everybody go on mute? Is not speaking, please. Okay.
we can't understand the discussion.
Rashmi ma'am, can you please unmute the person who is talking there?
Yes, sir. Yes, sir. I'm informing. Yes, sir. Yes.
Thank you. Thank you.
Okay. Okay, so we will start with looking at the Python. What can be seen on screen is a spider. So spider is basically an interface that helps you to code in Python language, and there are many other interfaces as well. So this Jupyter Notebook is one which is very popular. So whenever you're working on a cloud environment, Jupyter is a very handy tool to do. But mostly when you're working on a desktop environment, usually people prefer to use Python. So these are the two major differences between Spider and Jupyter. So if you try and understand how Python environment works. So Python is basically an environment. I know all of you know this quite well. So here what we are trying to use is some of the two critical libraries of Python which are known as pandas. Pandas is something which helps you manipulate or play with the data using data frames, and NumPy is something that helps you do the statistical analysis. So pandas and NumPy are some of the very popular libraries in Python, which are used for the purpose of managing data and performing the statistical data analysis. So to start with, what we are doing is, first of all, we are reading the data. We are reading raw data. We are importing the libraries first. Okay, so once we import the libraries, pandas and NumPy, we import it as quantity and NumPy as NP. And the next step is also to import the raw data. So raw data we are importing. I've stored that raw data in a CSV file format in one of my location in my the file. Uh, if all of you are smart, you can quickly respond. Are you aware with this Python interface, or are you confident about Python? Or do you study Python and Spider and all? No. So, any familiarity with Python? No. So, whatever responses you have received now, it's no. So, okay, we will go quite slow here, wherein the objective is to also understand the interface. It will help you to see where to see, what to see. So, this area is used for coding. So, here is where you write your codes, and the area on here where currently you can see this raw data is where you see your variables, or is where you see your results, as well as the bottom line is the console part where you can see where you can also see the output from the codes that you run. If there are certain messages, certain warnings, or certain errors, those all can be seen in this console. Okay, so basically we are going to use three sections here. There are many more, but we are going to use these three sections. One is where we are writing our codes. The second is we can see the output, we can see data frames, we can see charts. And the third one is where we can see if there is any message or warning or anything after running the Python codes. Okay, so we started importing the data, then we imported the raw data. So let me open the raw data and show it to you. Once we double click on it, is the overall world different. what are the different columns and what are different rows here. Okay, so to start with, what we have first is serial number, then we have a fault code. Okay, now I'm sure all of you understand when I say the fault code is normal or it is not normal or it is some P0125 in this code, then this fault code is actually a categorical data and it does not have any type of any type of natural order into it. Okay, so this fault code is a categorical data. Rest all of them, such as what is the pedal position, what is the ambient temperature, then what is the engine percentage torque. So these are some of my data that are numerical and continuous. So in this data set, what we are trying to do is it has mix of both. Okay, it has categorical data which has no order, and it also has numeric data. Now we are trying to establish the relationship between the numeric data and the categorical data. Here, the categorical data is the data of our interest. So once we read the data, now you understand that mean, to calculate mean, can we calculate mean of categorical data is a question. I request everyone of you to quickly answer on the chat screen. Can we calculate the mean of a categorical data? Can we calculate mean of a categorical data? Okay, we have one response, it is no. Then you're absolutely right, it's no, the answer is no. We have another response, no. Yes, no. Okay, so we cannot calculate mean of a categorical data. Then the difficult question now is, what do we calculate for the categorical data? We have studied this in your first part. What do we calculate for categorical data? To describe the centers of the categorical data. Wow, Shmika. Very good. Anyone else? Pallavi. Good. Yes, we calculate mode for categorical data. So right now, what are we calculating? Is we are calculating mean. Okay. So we're using a NumPy method which is known as np.mean, and then providing the modified modified data frame. Okay, so in this case we have tried to use both NumPy as well as pandas to show that okay these statistics can be done using NumPy also and pandas also. So we are calculating raw modified first, where we are dropping the serial number and fault code because we want to calculate mean only on numerical data and not on categorical data. So now if you see the raw modified table, it does not have any categorical data. We have removed the categorical data. Now it only has what we call as numeric data. Let's go and calculate what is the mean. So the method of calculating the mean, we are describing it as mean. We can also describe the raw mean. It means mean of the raw data. Then we are writing as NP. NP is nothing but NumPy library. So what we are doing is let's see here raw mean. We are declaring a variable. Then what is going to be the input of variable? We write NP as NumPy. Then when we click on P, full stop, it helps us with what are the different formulas that we can do here. So we can try in, and we should provide what is the data